Hello, this is Eloisa with Math Leopard. Today we're going to consider the Pythagorean reduction of partitions of the circle in both base 10 and in base 6. Let's note that 360, the number of degrees in a circle, has prime factorization equal to 2 cubed times 3 squared times 5. Hence we know there are 4 times 3 times 2 equals to 24, or the product of one more than each of the factors' powers, divisors of 360. To begin, 360 can be broken down as either 1 times 360, 2 times 180, 3 times 120, 4 times 90, 5 times 72, 6 times 60, 8 times 45, 9 times 40, 10 times 36, 12 times 30, 15 times 24, or 18 times 20. Hence, each of 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 20, 24, 30, 36, 40, 45, 60, 72, 90, 120, 180, and 360 divide 360. Let's consider the two bases I wish to conduct this analysis with. 6 is the product of the first two prime divisors of 360, namely 2 and 3, whereas 10 is the product of the primes 2 and 5. 6 is equivalent to the product of its proper divisors, that is 1 times 2 times 3, as well as the sum of its proper divisors, that is 1 plus 2 plus 3, meaning it is both product perfect and perfect respectively. The prime decomposition of 10, however, is composed of the number 2, representing the reflectional symmetry of man, and 5, representing the number of dactyls per limb, as well as the number of limbs plus the head. Hence 10 is a human number and base, whereas 6 is a celestial base, dividing the number of months, 12, degrees of right ascension, 360, and length of a Platonic year, 25,920. Let's begin with division of the circle by 2 to the nth power, reduced base 10. A perfect circle sweeps through 360 degrees, which can be broken up base 10 as 3 times 10 squared, plus 6 times 10 to the first, plus 0 times 10 to the 0th power, or 1. Hence, through Pythagorean reduction, we merely sum the coefficients of 10, that is 3 plus 6 plus 0, yielding 9. Division of the circle in 2 evokes the firmament into which the vibrational word brought forth the physical realm, this being 180 degrees from true nature or cosmic unity, breaks down as the sum of 1 times 10 squared, plus 8 times 10 to the first, plus 0 times 10 to the 0th, and summing 1, 8, and 0 gives us 9 yet again. Dividing the circle by 2 squared, or 4, represents a duality of darkness and light, night and day, and the 4 positions of the sun at dawn, midday, dusk, and midnight, giving us 90 degrees, which breaks down as 9 times 10 to the first, plus 0 times 10 to the 0th, whose Pythagorean reduction of 9 plus 0 is clearly 9. Dividing the circle yet again by 2 gives us 45 degrees, or 8 partitions, whose Platonic solid is an octahedron representing air. We see that 45 can be decomposed as 4 times 10 to the first, plus 5 times 10 to the 0th power, giving us 4 plus 5, or 9 yet again. When divided into 16 parts, the angle measure is 22.5, which is 2 times 10 to the first, plus 2 times 10 to the 0th, plus 5 times 10 to the negative first power. And when adding 2 plus 2 plus 5, we're left with 9. Dividing into 32 parts gives us 11.25 degrees, or 1 times 10 to the first, plus 1 times 10 to the 0th, plus 2 times 10 inverse, plus 5 times 10 to the minus second. Summing the coefficients 1, 1, 2, and 5s gives us, you guessed it, 9. Dividing into 64 parts gives us an angle measure of 5.625 degrees, or 5 times 10 to the 0, plus 6 times 10 inverse, plus 2 times 10 to the minus second, plus 5 times 10 to the minus third. And summing the digits 5, 6, 2, and 6 gives us 18. However, we can continue the reduction until a single digit remains, giving us 1 plus 8, or 9. Finally, dividing the circle into 128 partitions gives us 2.8125 degrees, or 2 times 10 to the 0th, plus 8 times 10 to the negative first, plus 1 times 10 to the negative second, plus 2 times 10 to the minus third, plus 5 times 10 to the minus fourth. Adding 2, 8, 1, 2, and 5s gives us 18, which, as we saw above, reduces to 9. Continuing with factors of 10, let's now divide the circle by powers of 5. As seen in our previous analysis, the decomposition of 360 itself leads to a Pythagorean reduction of 9. Dividing the circle into 5 parts gives us the most mystical of non-convex polygons, the pentagram. Representing the 5 vowel sounds a, e, o, u, reminiscent of ether, where the spark of intellect resides, air, the breath of wisdom attained over time, fire, the light of our spirit, earth, the calming force of reason, and water, the medium of self-reflection. This, of course, gives us an angle measure of 72 degrees, a profoundly significant number in many religions, but in particular the fraction of a day which Thoth is said to have gained from the moon, thereby adding 360 divided by 72, or 5 intercalary days. Breaking down 72 gives us 7 times 10 to the first, plus 2 times 10 to the 0th, yielding 7 plus 2, or 9. Next, dividing the circle into 25 parts gives us 14.4 degrees, or 1 times 10 to the first, plus 4 times 10 to the 0th, plus 4 times 10 inverse. Summing the coefficients 1, 4, and 4 gives us 9. Partitioning the circle into 125 gives us 2.88 degrees, or 2 times 10 to the 0th, plus 8 times 10 inverse, plus 8 times 10 to the minus second. Summing 2, 8, and 8 gives us 18, which further reduces to 1 plus 8, or 9. Division by 625 gives us 0.576 degrees angle measure, or 5 times 10 inverse, plus 7 times 10 to the minus second, plus 6 times 10 to the minus third. Summing 5, 7, and 6 gives us 18, which again reduces to 9. Dividing by 1 more power of 5 gives us 0.1152 degrees, or 1 times 10 to the minus first, 1 times 10 to the minus second, plus 5 times 10 to the minus third, plus 2 times 10 to the minus fourth. Summing 1, 1, 5, and 2 gives us 9. Hence, all divisions of the circle by powers of distinct prime divisors of 10 result in a Pythagorean reduction of its digits to 9. Now let's reconsider division of the circle by factors of 2, yet reduced using base 6. 360 can be expressed as a polynomial in 6 by 1 times 6 cubed, or 216, plus 4 times 6 squared, or 36, plus 0 times 6 to the first, plus 0 times 6 to the 0th, or 1. Hence, 360 is equivalent to 1400 base 6. Summing the digits base 6, we have 1 plus 4 plus 0 plus 0, or 5, reduced base 6. 180 degrees can be broken down as 5 times 6 squared, or 36, plus 0 times 6 to the first, plus 0 times 6 to the 0th, or 1. Hence 180 is equals to 500 base 6. Summing 5, 0, and 0 gives us 5 base 6. Division by 4 gives us 90 degrees, or 2 times 6 squared, plus 3 times 6 to the first, plus 0 times 6 to the 0th, equivalent to 230 base 6. This breaks down as 2 plus 3 plus 0, or 5 base 6. Dividing by 2 once again gives us 45 degrees, or 1 times 36, that is 6 squared, plus 1 times 6 to the first, plus 3 times 1, or 6 to the 0th power. Hence, 45 is equivalent to 113 base 6. 1 plus 1 plus 3 is, of course, 5 base 6. The next iteration yields 22.5 degrees, or 3 times 6, plus 4 times 1, plus 3 over 6, that is 1/2, or 3 times 6 inverse. Hence, 22.5 is equals to 34.3 base 6. But the sum of 3, 4, and 3 is going to be 1 times 6 plus 4, or 14 base 6. We then further reduce this to 1 plus 4, or 5, as we've come to expect. Division by 32 gives us 11.25 degrees, or 1 times 6 plus 5 times 1, 6 to the 0th, plus 1 times 6 inverse, or 1/6, plus 3 times 6 to the minus second, or 1/12, yielding 15.13 base 6. Summing the coefficients 1 plus 5 plus 1 plus 3, or 1 times 6 plus 4 times 1, that is 14 base 6. Hence, 1 plus 4 gives us 5. Partitioning the circle into 64 gives us 5.625 degrees, or 5 times 1, 6 to the 0th, plus 3 times 6 inverse, which we know now is 1/2, plus 4 times 6 to the minus 2nd, or 1/9, plus 3 times 6 to the minus 3rd, or 1/72. This gives us a value of 5.343 base 6. Reducing to 5 plus 3 plus 4 plus 3 is going to be twice 6 plus 3, or 23 base 6. This further reduces to 2 plus 3, or 5 base 6. Dividing the circle by 128 gives us 2.8125 degrees, or 2 times 6 to the 0, plus 4 times 6 inverse, 2/3, plus 5 times 6 to the minus 2nd, or 5/32, plus 1 times 6 to the minus 3rd, or 1/216, plus 3 times 6 to the minus 4th, or 1/432, yielding an equivalent value of 2.4513 base 6. Summing 2, 4, 5, 1, and 3 gives us twice 6 plus 3, or 23 base 6. This, of course, reduces to 5. Finally, let's partition the circle by factors of the second prime divisor of 6, namely 3. Beginning with the complete circle, we've seen in our previous analysis that 360 is equivalent to 1400 base 6, which when reduced gives us 5 base 6. Dividing the circle into 3, we come upon the most important number in occult practice. 3 represents the celestial, terrestrial, and chthonic realms, as well as the 3 graces, elegance, beauty, and joy, aglaia, thalia, and euphrosine, respectively. The 3 fates, clotho, lachesis, and atropos, postnatal chi, destiny, and death, respectively. And the 3 furies, Tisiphone, Megara, and Alecto, enacting justice in the form of retribution, grudges, and unceasing castigation. 3 also represents the phases of the moon within the various realms of creation, the new moon in the chthonic realm, the waxing and waning rooms in the terrestrial realm, and the full moon within the heavens. 3 is also seen in funerary rites, wherein mourners circumambulate the grave 3 times, as well as in the performance of incantations, wherein repetition by a factor of 3 is frequently seen. This gives us 120 degrees, which can be expressed as a polynomial in 6 by 3 times 6 squared, plus 2 times 6 to the first, plus 0 times 6 to the 0th, equivalent to 320 base 6. When summing the digits 3 and 2, we arrive at a value of 5 base 6. Dividing the circle by 9 gives us 40 degrees, which breaks down to 1 times 6 squared, plus 0 times 6, plus 4 times 6 to the 0th, or 104 base 6. This, of course, reduces to 1 plus 4, or 5 base 6. Dividing the circle by 27 gives us 13.333 degrees, which I've truncated for our purposes as 0.3 bar is equivalent to 1/3. This can be written as 2 times 6 to the first, plus 1 times 6 to the 0th, or 1, plus 2 times 6 inverse, or 1/3, representing the 0.3 bar to the right of the decimal, being equivalent to 21.2 base 6. Summing 2, 1, and 2 gives us 5 base 6. Next, dividing the circle by 81 gives us 4.4444, once again truncating the repeated decimal, which is equivalent to 4/9. This can be broken down into 4 times 1, or 6 to the 0th power, plus 2 over 6, or 2 times 6 inverse, plus 4 over 36, or 4 times 6 to the minus 2nd, yielding 4.24 base 6. Summing 4, 2, and 4 gives us 1, 6 plus 4, or 14 base 6. This can be further reduced to 1 plus 4, or 5 base 6. Finally, dividing the circle by 243 gives us an angle measure of 1.481 bar degrees, where 0.481 bar is equivalent to 481 over 999. This can be written as 1 times 6 to the 0th, plus 2 times 6 to the negative first, plus 5 times 6 to the minus 2nd, plus 2 times 6 to the minus 3rd, or 1.252 base 6. Summing these digits gives us 1 plus 2 plus 5 plus 2, or 1 times 6 plus 4, that is 14 base 6, which of course reduces to 1 plus 4, or 5 base 6. Hence, divisions of the circles by powers of 2 or 3 always have a Pythagorean reduction to 5 base 6. It may seem like this would work for any divisor of 360 whose prime factorization consists of the product of two distinct primes. However, 15 fails to reflect this conjecture. There is something very unique about base 10, but even more so, in my opinion, about base 6. To prove that if 9 divides an integer n, then it also divides the sum of the digits of all subsequent divisions of n by either 2 or 5, let's consider n given by the digits d sub m minus 1, d sub 1, d naught. If 9 divides n, then 9 divides the sum of the digits of n. That is, d sub m plus d sub m minus 1 plus d sub m minus 2 plus plus d naught. This implies that 9 divides n equals to the sum as index counts from 0 to m of d sub index 10 to the index. That is, d sub m times 10 to the mth power plus d sub m minus 1 times 10 to the m minus first power plus plus d sub 2 times 10 squared plus d1 times 10 to the first plus d naught times 10 to the 0th. I'm going to factor out a single 10 from each term but the last, leaving us with 10 times d sub m 10 to the m minus first plus 10 times d sub m minus 1 10 to the m minus second plus plus 10 times d sub 2 10 to the first plus 10 times d1 plus d naught times 1. Hence, when we divide n by 2, each of the 10s we factored out in the previous step becomes 10 over 2, or 5. I'm then going to rewrite each of the remaining 10s as 9 plus 1. Hence, we're left with 5 times d sub m times a quantity 9 plus 1 to the m minus first power, plus 5 times d sub m minus 1 times a quantity 9 plus 1 raised to the m minus second power, plus plus 5 times d sub 2 times a quantity 9 plus 1 to the first power, plus 5 times d1 plus 1 half d naught. Next, we express each of the binomial quantities, 9 plus 1 raised to the power of the term minus 1, as a sum, and the coefficient of d naught as 5 over 10. This gives us 5 times d sub m times a sum as index counts from 0 to m minus 1 of m minus 1 choose index times 9 raised to the index for the first term, plus 5 times d sub m minus 1 times a sum as index counts from 0 to m minus 2 of m minus 2 choose index times 9 to the index, plus plus 5 times d sub 2 times a quantity 9 plus 1 plus 5 times d1 plus 5 over 10 times d naught. I'm going to simultaneously factor the 5 from each term and tack off the 0 indexed first term in each summation, grouping them at the end. It's interesting to note that the 0 indexed term has a value of k choose 0, which is 1, times 9 to the 0th power, which is also 1. Hence the first term of each sum is 1. This gives us 5 times the quantity d sub m times the sum as index counts from 1 to m minus 1 of m minus 1 choose index times 9 to the index, plus d sub m minus 1 times the sum as index counts from 1 to m minus 2 of m minus 2 choose index times 9 to the index, plus plus d sub 2 times 9, to which we then add 5 times the sum of d sub m plus d sub m minus 1 plus plus d1 plus d naught over 10, where each of the d sub m through d sub 2 were multiplied by the first term values of 1 in each binomial. As we can see, each remaining term in the summations has a factor of 9 to a power greater than or equal to 1. Hence, this whole underbraced sum is divisible by 9. That is, there is some positive integer m for which this sum is 9 times m. Let's rewrite this expression using 9m in its place, yielding 9m plus 5 times a quantity d sub m plus d sub m minus 1 plus plus d1 plus 1/10 of d naught, or 0 point d naught. It should be clear that because 9 divided the sum of the digits of n, that 9 divides the sum of the digits in this underbraced expression. Hence, 9 divides 9m, and 9 divides the sum of the digits of n, meaning that 9 divides the sum of the digits of n over 2. Next, we look at division of n by 5. This gives us 2 times d sub m times a quantity 9 plus 1 raised to the m minus first, plus 2 times d sub m minus 1 times a quantity n plus 1 to the m minus second, plus dot plus 2 times d sub 2 times the quantity 9 plus 1 plus 2 times d sub 1 plus 1 over 5 times d naught. Expressing the binomials in summation notation and rewriting 1 over 5 as 2 over 10 gives us 2 times d sub m times the sum as index counts from 0 to m minus 1 of m minus 1 choose index times 9 raised to the index plus 2 times d sub m minus 1 times the sum as index counts from 0 to m minus 2 of m minus 2 choose index times 9 raised to the index plus plus 2 times d sub 2 times the quantity 9 plus 1 plus 2 times d1 plus 2 over 10 times d naught. Once again, let's take off the 0 indexed first term of each sum and factor out the 2 simultaneously. This gives us 2 times the quantity d sub m times the sum as index counts from 1 to m minus 1 of m minus 1 choose index times 9 raised to the index plus d sub m minus 1 times the sum as index counts from 1 to m minus 2 of m minus 2 choose index times 9 raised to the index plus plus d sub 2 times 9, to which we add 2 times the quantity d sub m plus d sub m minus 1 plus plus d sub 1 plus d naught over 10, where each of the dm through d2 came from the first term of each binomial sum. Yet again, each term remaining in the binomial sums has at least one factor of 9, hence can be written as 9m for some positive integer m. This gives us 9m plus 2 times the sum d sub m plus d sub m minus 1 plus plus d1 plus 0 point d naught, which by our argument for division by 2 has a digit sum equivalent to that for n. Hence, given that n divides both 9m and the sum of the digits of n, we have that 9 divides the sum of the digits of n over 5. Thus, it is shown. Thanks so much for watching. I'll be making new videos soon, so please subscribe to be notified when they're released. Thanks for playing, and I'll see you next time.